Okay, we're going to add our third rectangular approximation, which stands for MRAM, which stands for middle RAM. So we have left RAM, we have right RAM, and now we're going to have middle RAM. And then we're going to also finish with using our calculators, and I'm going to use those programs today. Okay? All right, so yesterday we saw that LRAMs and RRAMs were varying degrees of accuracy based on whether or not the function was primarily increasing or primarily decreasing. So depending on the direction of the function, the type of RAM you do is going to give you one or the other. So the question we want to tackle today is, how can we do this better? Sure. Okay. And so what we want to do is put neither the left corner nor the right corner, but we want to put the middle of the rectangle. What?
No, that just didn't make sense.
Okay. All right. So an even better way would be to put the center of the rectangle, the middle of the rectangle. So if I could zoom in on that, if you can just sort of contrast for yourself, would be the left corner touching the curve. Here would be the right corner touching the curve. And an even better way would be to put the middle of the rectangle right through the curve. Okay, why is that better? You say it makes sense. Why?
It's not just an overestimate or an underestimate. It's more in the middle, so you get a little bit of both.
Okay, great. Yeah, so if you're doing an entirely LRAM, they're all going to be under. And it's going to be entirely an underestimate. If you're doing a complete RRAM, everything would be an overestimate. But if you do the MRAM, you get a little bit of both. For every rectangle here, we've got a little bit of an overage and a little bit of an underage. And those two things cancel each other out to give you even more accuracy. So the idea of an MRAM is better. Now, an MRAM is not an average RAM, which is what you were doing yesterday. I need to be clear with you about that, because that is something that a lot of students have a misconception about. They think, well, I was doing LRAM and RRAM and I was averaging them. Isn't that the same thing as doing an MRAM? The answer is no, because you are dealing with curves. You're not dealing with linear things. If it was linear, then yes, an MRAM would be the same as an average. But when you deal with something curved, it's not an exact canceling out. It's close, but those little wedge things that I colored in are not equal. If it was linear, it would be equal. But these wedge pieces are not, because one of them is slightly larger than the other, depending on the concavity of the curve that you're dealing with. So I need you to be clear that an MRAM is not the same as an LRAM. Like, it's not the same as an average of an LRAM and an RRAM. MRAMs take more data. You can't do as many MRAMs as you can with LRAMs and RRAMs with the same amount of data, because you have to skip the one in the middle. Let me give you so in other words, this graph we did yesterday, we separated into 6 columns. For MRAM, you can only separate it into 3. So go ahead and take your device and separate this into 3 different ones. That's all that you can do when you're dealing with M. Because you have to have a middle value. And so we can't use what would normally be in that middle value for our, so we're going to use 0.5 as our middle value. We're going to use 1.5, and we're going to use 2.5 as the middle values for our MRAM. I want to start with the 2.5, okay? Can we go to the 2.5 and go up to its position on the curve above, so you'll be right in the middle of the value, and then draw what will be your rectangle, so it's partially above and partially below. So your rectangle has a little give and take. It's got an overestimate on the left side, it's got an underestimate on the right side. So let's call that our M3. Okay, that's the middle rectangle, the third one. What are the dimensions of that? What's the base of it from side to side, and what's the height of it? So if you're measuring from side to side, where are you measuring from? What is this number to this number? Well, what are the numbers? 2 to 3. And so because I'm measuring 2 to 3, the width between them is 1. But the height is found in the middle. And how tall is that?
6.7.
Okay, well, it is this height right here. So when I'm doing my MRAM, all of my rectangles will be 1 by. This last one happens to be 1 by 6.75. The one at 1.5, which goes from 1 to 2, still has a base of 1, but its height in the middle, okay, where it partially overestimates and partially underestimates. What's its height, that M2? Okay, it is this one at 3.75. And then finally, my one that was the what I'll call M1, okay, it has a base of 1, and its height here in the center, and look at where that center value is. What is the difference between that rectangle and the other two I've done so far? Say it again, Tyler. It's completely both under. It's an underestimate for both of them. And so overall, this is going to be still an underestimate, but it's way better than what we've done before. It has 2 rectangles that are really good because it has both an under and an over, which cancel each other out. But rectangle, the first rectangle, because both sides of it are under due to the concavity of this graph, it's going to be an overall of an underestimate. So that's one, we're using this one, 2.75. So do you see how we're using fewer of the data points? So it actually goes faster. And it's a better estimate, so win-win, okay? It goes faster, and it's a better estimate. And so if somebody can, Sam, can you grab your calculator and add those up? Do you have it out? Yeah, add those MRAMs. Okay, 13.25, which fits what we did yesterday. We did LRAM and RRAM to this, and if I remember, our LRAM was like 12 point something, and our RRAM was 15 point something, and this is the best estimate in between, but it's not the average. It's not exactly in the middle of the LRAM and RRAM, okay? It is a better estimate. All right, so I made a slide for this because I wanted to be clear. MRAM is not the simple average of LRAM and RRAM. Can you bet that on a multiple choice they are going to put that on there as an option? They're going to put the average of LRAM and RRAM on a multiple choice question to see if you know your stuff, to see if you know whether or not that MRAM is different. Okay, can somebody articulate for me in your own words, why not? Why is MRAM not just the simple average?
Because you're not dealing with something that's linear.
Right, because we are not dealing with linear functions. Our functions have curvature and concavity. Therefore, it's not equal to the simple average. Okay? Because most functions are not linear, which would be the only case in which they would be equal to the average, but have curvature and concavity. Okay, so MRAM is the best estimator so far that we have because it minimizes the error or the gaps. Okay. Now, because I said so far, then you should be anticipating that there might be other estimating strategies that are even better than MRAM, but so far, of all the rectangular ones, MRAM is the best. Okay, now, if I told you to do 6 of them, what are you going to need to find? If I told you to do 6 instead of 3. So if I told you, all right, we just did this one, but now split all of those in half. Do you have enough information to do that? Why not? I heard a no.
I don't have the height points.
Okay, I don't have, where would I need a height point at?
Point.
So before, my height points were at 0.5, 1.5, and 2.5. Now where am I going to need height points for?
0.25.
I'm going to need a height point at 0.25. Where else am I going to need a height point?
1.75.
Okay, 0.75. Where else? 1.25, 1.75, 2.25, 2.75. So I'm going to need more heights than are available to me on my table. But I do have an equation.
Okay, then you can do it.
Okay, I do have an equation. All right, so Nathan Deere, I'm going to assign you 0.25. Would you please find us the height value using the equation? Isaac, do 0.75. Noah, do 1.25. Carla, do 1.75. Brendan, do 2.25. And David, do 2.75. Okay, so using your calculators and the given equation, even though they're not on the table, we're filling in some of the gaps on the table. And so we're going to work through just using the equation. Just use your calculators to do that. Nathan, are you ready?
2.8125.
Okay, so what Nathan is saying, and we'll see it. Okay. This is 0 and this is 0.5, and you're saying that the height in the middle at 2.25, tell me what you said you thought it turned out to be? 2.8125. And so his height there will partially underestimate and partially overestimate. And so we've got a really good estimation right there for our first rectangle. So Nathan, altogether, what is, I'm going to do MRAM 6. What are the dimensions of your rectangle? Now, how long is the base?
0.25.
No, the base is not 0.25. Let's take a look at that again. The base measures from side to side. The base measures from left to right. The base does all the way. It's only the height that measures at 0.25. So what is the base? Okay, the base is 0.5 times, and then you said the height was, I gotta zoom in, just 2.8125. Okay, Isaac, we're ready for you. What is the base of your rectangle?
0.5.
Also 0.5, so we'll be adding that. And what is the height of your rectangle?
2.8125.
Oh, it's the same. Does that make sense to you?
Yeah.
Why?
Because it's going from decreasing to increasing.
Okay, because we just swapped, and so it is the exact same. 2.8125, so you've got the exact same, those two back to back. All right, Noah, we're ready for yours.
0.5.
Okay, base is 0.5. What's your height?
3.8125.
Okay, thanks. Sam, can you be adding up the heights for me as we go for everybody's? Okay, Carla, we're ready for you.
0.5.
Oops. Okay, ooh, plus, okay, good job. And?
And then times the 4.3125.
Okay, good. Oh, yeah. Did I miss a
3.3.
3 point? Okay, sorry, thanks. I just didn't get all your decimals. Sam, you got that? 3.3125. Okay, Brendan, we're ready for our fifth one.
Base is 0.
Mm-hmm.
And then height is 5.8125.
Okay, and David, we're ready for yours.
0.5 and 7.8.
There's got to be more than that. So not 7 point?
It's 7.81.
7.8125. All right, Sam, you got a grand total for us?
The heights are 26.875.
The heights are 26.875, and all of these have the common base of 0.5 for a grand total of?
13.4375.
How does that compare to what we just had? What did we have before? 13.125?
Just 13.2.
13.25. Okay, so now we're even more accurate. So more divisions meant a greater accuracy. So how do you get more? Split it again. Okay? So we're going to use our calculator program to split these like 100 times. Okay? Now, you'll be required to never really do more than about 6 by hand. Okay? Like to show the breakdown of it. But with a calculator, you can split it 50 times. You can split it 100 times. Okay, so grab your calculators for me. All right, in your y equals, go ahead and put in this parabola that we're working with. So x squared minus x plus 3. That should be in y1. Then quit out of there and activate the program. So go to your programs that I downloaded. And you should have a program on your calculator called RAM. Okay, go ahead and activate RAM. And it's going to ask you your first question. Okay, what's the first question? A value. That means where are you starting as your lowest on the x-axis, your lowest one. So what's our lowest? 0. Okay, then it's going to ask you another question, which is B value, which is where are you supposed to want me to end? And so we're stopping where?
3.
At 3. Okay, and then enter again, and then it'll ask you another question, number of intervals. Okay, so we just did 6. Go ahead and put 6 in, hit enter, and oh good, we did it right. So it tells you the left, the middle, and the right. Do you see how the left is the lowest, and the right is the highest, and then the middle is the best? That's with 6 intervals. Okay, let's run the program again. So activate your program again. Okay, A value is still 0, B value is still 3.
Oh, no.
Now increase your number of intervals. It's usually nice to do powers of 2 in your intervals. So we did, or something even, but you know, do 32 or 36 or something like that, but do a higher number of intervals. The higher you go, the more your calculator does have to work a little bit, so it may be a slight delay. Don't do like, if you're gonna do 1,000 intervals, your calculator's sort of gonna get, did it do it?
Yes.
It's still working.
Did it?
Yeah.
Is it still working?
That was a nice parabola. The more complicated the equation, you literally might have to set your calculator down for about 5 minutes while it works. It depends on how complex the equation is, okay, and how many you're doing. All right, so yeah, somebody, do we seem to be narrowing down to as like if you did 1,000, what were your left, mid, and right?
Left is 13.4910045.
Okay.
Right is 13.50900045. And mid is 13.4999977.
So in your most educated opinion, what do you think is the actual answer to this?
Pretty much 13.5.
Pretty much 13.5, okay? And that's exactly right there. That's exactly right. All right, let's go to the next one. Okay, this is our last one, I think. A car is traveling down a road. You have select values of velocity. Use MRAM and all you have is the table. We have no other information. We do not have an equation to work with. What is the most MRAM divisions we can make with the data that's given? No?
MRAM division?
MRAM divisions. Okay, well, let's start. How many LRAM divisions could you do? 6. There are 7 numbers. If there's 7 numbers, you have 6 intervals, right? So if you're doing an LRAM, it would be 0 to 7, 7 to 12, 12 to 20, 20 to 26. Okay, so that's 1, 2, 3, 4, 5, 6 intervals. If we're doing MRAM, we can only get 3. And so our 3 are going to go from 0 to 12, from 12, which you can share, to 26, and from 26 to 35. Okay, so we can only get 3 out of that. All right, Nathan Schlossman, what is the base of my first M division? 12. Okay, my base is 12. What is going to be the height of my first MRAM division?
36.
Good job. He used the 7 to get the height, which is at 36. All right, Tyler, what is the base of the next MRAM division? 14. Oh, not the same. Okay, so don't just assume it's going to always be 12. All right, and what's the height of the next MRAM division?
44.
Make sure you're using M. You just used R. You used the right. Use the number in the middle.
48.
Yeah, you got to use the number in the center, the middle, which is 48. Okay, Sean, what is the base of the last M division?
9.
Okay, and what's the height of the last M division?
40.
40, okay? So that is the M part. All right, so we have different values of time, so it's not all consistent, so we will need to add these up. 12 times 36, 14 times 48, 9 times 40. All right, Andre, got an answer for me?
1,464.
Anybody second that?
Yeah.
Okay, and we need units. Okay? Feet. Okay, units are feet because we multiply the units of seconds times the units of feet per second, which just gives us feet. So that estimates the distance.